In this video, I wanted to continue our conversation that we've had on atoms, but I also want to bring in some new concepts around isotopes and ions. So let's first just reflect on what we've learned before. So to find the atomic number of an atom, this is always going to be equal to the number of protons. The atomic mass of an atom is going to be equal to the protons plus the neutrons. And the reason for that is the reason we don't have electrons here is because even though they're in the atom, their size is so much smaller that it's not going to be something that's really going to change the overall size by very much. Okay, so now we're going to kind of move into a new topic, and we're going to talk a little bit about isotopes here. And isotopes is really just an atom with a different number of neutrons. So it has a different number of neutrons. And really this fact that it has a different number of neutrons, we have to remember that every neutron has one AMU. And because of that, this is going to throw off the mass of the atom, or isotope in this case. So let's just look at an example of a regular atom. So we'll look at nickel 58. And nickel, if we look at on our periodic table, we can see that nickel is the 28th element. So therefore it's going to have 28 protons. And because it has 28 protons, it's going to have an equal number of electrons to balance the positive charge. Well, the last fact, the last subatomic particle that we have to solve for here is the neutron, and we know that the atomic mass equals the protons plus the neutrons. So really, we just have to take 58 minus 28, and that will give us 30 neutrons inside of nickel 58. Now let's say that we have nickel 60. Well, what's going to change here? Well, the proton number is going to be the same because it's still nickel, and the protons represent the identity of the atom. In other words, 28 protons is indicating that this is nickel. So we still have nickel, so we're still going to have 28 protons. That's not going to change. The neutrons, however, are going to change because here the weight is represented by this 58. I could also write this, not to get off topic here, but I could also write this nickel 58 like that. And I know, and the reason that I don't have anything here is because I already know that because it's nickel, it's going to have to be 28. So I can actually leave that 28 out, and I can just write 58 nickel or nickel 58. So here we have nickel 60. So again, the mass is 60. So I have to take the 28 protons here and subtract them from, I have to subtract them from 60. So I'm going to get, let's see, 32 neutrons here. And the electrons are going to balance the charge of the protons. So they're going to be 28. So just like that, we've solved for nickel 60. I'm going to do one more, and I want you to pause the video and attempt to do this one here. Let's do Fe, let's see, Fe 63. So try that one. Okay, so hopefully you give that a shot. In terms of protons, we look on our periodic table, and we see that iron is Fe, and the atomic number is 26, so that it must have 26 protons. And right away I can tell that this is going to be 26 electrons because the charge has to be balanced. And now I'm going to look at the number of neutrons. Well, what is 63 minus 26? That's going to be 37. So I know I'm going to have 37 neutrons here. Okay, and just to note, to get into a little bit more detail on isotopes now, which it's okay if you don't understand this completely now, but isotopes are common forms of radioactive decay. or I guess I should say, let me rewrite this actually, I want to be clear, commonly involved in radioactive decay, just so I don't confuse anyone. And the reason for that is because the nucleus is not stable. It is not stable because it doesn't have the intended number of neutrons, so the nucleus is constantly decaying away. Like in this nickel-60, for example, the nucleus is constantly decaying away over some period of time and losing these neutrons, and eventually in some cases you can actually lose protons also that would actually change the form of the atom. And we'll talk about this when we talk about nuclear chemistry, but for now it's just kind of a good idea to get an understanding of it. In the next video we're going to go over ions and see how all of this can come together for us to be able to find the different subatomic particles in a molecule.